Hello, everybody. My name is Kosa from Ethernal, and today I'm going to talk about immutable future, how to craft trustworthy AI with the blockchain. So let's start. In this presentation, I will talk about AI. I will explain a few definitions and AI concepts. I will go through core blockchain features. Then I will join these two worlds together and explain how we can benefit from blockchain in AI. Afterwards, I will say a few words about our enterprise blockchain that we have built at Ethernal and give a few use cases how we can apply blockchain in different AI processes. In the end, I will give a conclusion about this topic. So let's start. What artificial intelligence is? It's the capability of a computational system to perform human intelligence tasks. These tasks include learning, reasoning, decision-making, perception, language understanding, problem-solving, and at the same time, artificial intelligence is a field of research in computer science that develops and studies methods and software that enable machines to act intelligently. Today, we are living in a world where popular large language models are overwhelmed, let's say. They're used across different products, and with them, AI systems are becoming increasingly complex and autonomous. And at the same time, these AI systems are adopted across industries, and they are affecting decision-making processes, and that is why we have to be very careful how we use AI, especially if we rely on results of the AI. The other thing is machine learning. Machine learning is a subfield of AI. It basically gives computers ability to learn without being explicitly programmed. Here on this diagram, we can see what machine learning does. We have a machine learning program or system that has training data, which is input data for training. We have a basically plain model, and after training is done, we get the training model with parameters that suit to training data. Once we have a trained model, we can leverage that trained model to derive results, predictions, to make predictions about new data based on the trained data. So this is important. We have a new data, we have a trained model, and we have results, which are predictions. Now we come to generative AI. This is a buzzword these days. And what generative AI is, it is basically AI that creates new original content in response to prompts. These prompts here are basically new data that we saw previously on diagram. Here in this image, we can see relation between different parts of artificial intelligence. We have a machine learning, which is a subfield of artificial intelligence. We have a deep learning, which is a subset of machine learning. And here we have a generative AI, which is basically a subset of a deep learning and large language models that are also part of the deep learning, but they are not the same. There is a difference between large language models and generative AI. And that difference is basically with the LLMs in the multimodality, because well-known models like GPT, Gemini, Claude are large language models that can serve as, which are empowered with the generative AI. So they're in intersection of these two. This multimodal large language models can understand, process, and generate multiple data types like text, imagery, audio, video code, structured data, etc. And now that we have these models here, which basically create original content, which is new, we have to be sure that the outputs of AI are trustworthy, and there is a catch, essentially. So what happens in AI models is that we have a number of anomalies. Here are several categories of anomalies that we have. They include data anomalies, model behavior anomalies, training, inference, security. ethical life cycle anomalies. And as we can see, each category has a number of different types of anomalies. I will just mention a few. For example, biased data sets can lead to biased results. For example, it will bring like systemic prejudice in the results. And once we have something like that, that will also affect ethical and social aspect of the result, because we will introduce stereotyping. Another anomaly is, for example, hallucinations. This is something that is frequently mentioned these days because AI models generate content, and although that content looks reasonable, it is factually incorrect. And you have to have a wide knowledge, critical thinking, every time when you analyze the results or when you want to rely on the results of, for example, large language models. I can also mention prompt sensitivity. This means that when you change inputs for the model, you get very different results for the small changes in the input. Okay, we can continue. Now that we have saw what AI is and what are its parts, let's see what is a blockchain. So you are all already familiar with the blockchain. It is a distributed ledger. Basically, it is a long list of cryptographically linked blocks. Core features are the features that are important for this, let's say, merge between AI and the blockchain. So core features are decentralization, immutability, transparency, and cryptographic security. Decentralization is basically distribution of control and authority across all network participants. Immutability means that once transaction is recorded into a block on the blockchain, it cannot be deleted or altered by any single party. Transparency: all transactions are visible to participants who have access to the network, and cryptographic security: data on a blockchain is secured through cryptographic techniques, which makes unauthorized access unavailable, and it also enables that the blockchain is resistant to tampering. One thing that also has to be mentioned is that we have a programmable infrastructure on a blockchain. For example, on EVM blockchains, we have smart contracts. On other blockchains, we have programs, etc. And this is, I mentioned this because in the examples that we will see, we will use smart contracts. Now that we have saw these two worlds, we basically have two sophisticated technologies which operate on different paradigms. The first one, AI, involves adaptive learning processes, and it includes probabilistic logic, while on the other side we have deterministic and immutable ledger. So these both technologies are reshaping the industry today, and it is interesting to see how they can be, let's say, joined and what opportunities it can make. The key challenges of AI include transparency, accountability, and data integrity, and we will see how blockchain can solve these issues with the core features. Now that we recapped about blockchain, let's mention our blockchain. This is a Blade. It is basically cutting-edge private blockchain platform. It is designed with a clear focus on enterprise needs. It is basically EVM-compatible blockchain, which supports typical Ethereum blockchain features. On the top of that, we also offer enhanced features like improved scalability, faster transaction processing, free transactions when it is required, And the thing that we have developed recently is a built-in bridge to EVM-compatible networks. And now let's go to the use cases. I will present several use cases which show how we can use blockchain in AI processes. The first one relates to dataset preparation. The second one is related to enhanced AI model training. The third one is secure and verifiable AI inference. And the fourth one basically joins the previous three together. So in this figure, we can see how dataset preparation process looks like and what is added on the top of it to integrate blockchain. At the beginning, we have inputs. These inputs are usually taken from the internet. They are taken from the web as web scrapes. Then we have a user data sets, or, for example, data that is taken from IoT devices. Once that we have that data comes in different formats, and what we have to do is to pre-process these inputs. As a result, we get data set metadata, and we get a data set. This data set is basically pre-processed, where we have done pre-processing, like filtering, normalizing, augmenting. And when we have these two, we can create a hash of data set and a hash of metadata, and store those hashes on a smart contract on a blockchain. Here, for example, we have a data provenance smart contract where these two hashes are kept. Metadata dataset takes care of information about the sources for the dataset, what type of processing was done, who is the owner of the original data, who is the owner of dataset. The dataset and the metadata are kept usually off-chain. Okay. So what can we can also say that this data set can be large. So in order to create hash, we have to do something like splitting data set in smaller parts and creating hash of those parts, and then applying some cryptographic technique like creating a Merkle trie of the hashes to create a Merkle root hash and store that hash here on the blockchain. Okay, now we have a data set. After that data set is created, we can leverage data set and other data sets to train a model. So the process starts with the regeneration of a data set hash. Why we do that? We want to ensure authenticity of the data set. That is why we take hash, newly created hash, and check it on the hash that is stored on the blockchain. After the verification was successful, then we can continue with the training of our model. When model is trained, we can create a hash of that trained model, and at that time we can register a model hash on the smart contract, the other smart contract on the blockchain, and at the same time we can register an event describing the process of training. Basically, this event includes model version, owner of the data set, owner of a trained model, for example, access rights, what data set was used for training, or data sets were used for training, and similar stuff. Okay, now we have a verified data set. We have a trained model that is stored on the blockchain. Now we can infer new knowledge from our trained model. Now the first step is to do verification of the hash of a trained model that we want to use, and to give input to our trained model. This is inference data. This is like a new data from one of the first slides. Then we go into inference process, and we get output of that process, which is some result. When a result is created, we generate a hash of the result and the proof. Both hash and the proof are also stored on a smart contract on a blockchain. Why we do that? We want to take care of data integrity of the result. At the same time, we want to prove that how training was done, how inference was done from the inference data and what was the result. At the same time, this proof can hide the privacy, private data that were used in this inference process. So we can, for example, use ZK proofs here and store everything on a AI inference smart contract. Okay, now this is the last diagram, which basically shows DI application inference process, where basically we encapsulate everything that we saw. We have a user which enters decentralized AI application. It authenticates through wallet. Basically, through this application, user selects a model that he wants to use, creates prompts that he wants to use with the trained model. Basically, it calls inference. Once this transaction, which calls inference, is called with its inputs, transaction log records that transaction request, and decentralized compute node read events. Once the event is recognized by this compute node, it fetches appropriate model. That model is verified on the blockchain, and it is executed with the inputs that were given by user. Results are saved in the result storage, and this everything happens on off-chain. When result is saved, at the same time we create a result hash and a proof, and these are stored on the blockchain. And when this is done, user can use this result hash to retrieve results from the storage. So with this approach, basically different phases in AI, in different phases of AI processing, let's say, are captured on the blockchain. We saw data set, we saw training model, we saw inference, and now we also see user calls. Okay, now that we have gone through all this, we saw that AI has complex challenges, which include transparency, accountability, and data integrity. And we also saw what the core features blockchain offers. With these core features, we basically address AI concerns. And opportunities that were created through this join are, for example, enhanced data security and integrity. We also have improved model traceability and version control. We have transparent and verifiable audit trails. We have execution on a smart contract, and we have reliable provenance and compliance. So we can suit these processes to fit into different regulatory rules, so we can comply with everything that is needed. And one thing that I also have to mention is that we have recently created blockchain in AI use cases white paper, so you can find more details about this topic in this white paper. We have developed it together with the Cybergate Defense recently, and you can check it. And that would be all from me.